Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
We are live. Hello, everyone. Hey, I'm Wasim. Greeting from France. Bonjour. I'm so thrilled to be here with you today. I hope you're enjoying this event so far, and I can't wait to see all of your submissions. Today, we are going to dive into something cool, really cool, which are AI agents. And of course, I know you've probably seen the previous presentations for the other programming languages, .NET, Python, that are done by my amazing colleagues. But this session is so special because it's in JavaScript. And we all know that JavaScript is so cool. And you can even build cool agents with it. So in this presentation, I'm going to show you how to create your very own AI agents using JavaScript and TypeScript, and also Azure AI Agent Service. Whether you're a seasoned dev or just starting out, you will find that building agents is not only powerful, but also a lot of fun. So after you learn how to build your AI agent with JavaScript, you will get a chance to show off your amazing skills in the hackathon. And it's a fantastic opportunity to get creative and maybe even win some cool prizes. So yeah, buckle up and get ready for an exciting journey. And by the end of the session, you will have your very own AI sidekick ready to tackle any challenges and impress the hackathon judges. So yeah, let's get started. Okay, so as I said, in this presentation, we're going to learn about agents and understand their basics. We're going to briefly talk about the Azure AI Agent Service and its features. I know my colleagues have covered it all in their presentations, so I'm just gonna do some recap here. And we will basically spend most of our time in VS Code, reading and writing some code in order to learn how build your agent with JavaScript. So all the demos we're going to use for today's session are hosted in this repo. So please fork it, clone it, run it, and deploy it on Azure. And if you like it, please give it some stars. We'll appreciate it. So yeah, before we dive into the code, a little bit of history. You've probably seen this slide before, shared by my colleagues. I find it to be really interesting, to take some time to understand why do we need agents, the AI agents, and what's their added value. So yeah, let's look at the AI progression in the last year or so. So as you know, we started with interacting directly with the LLMs as a chatbot, like in 2016, I believe, when we used to do chatbot apps using NLP-based solutions. But this time is different because we're using more powerful language models and generative AI. And it all started back in November 2022 with GPT 3.5. LLMs can, take natural language as input and reply with many languages. They can process multimodal IOs. They can help carry out tasks and act as tutors. In terms of user experience, they provide a simple back and forth chat experience with users, with us. And they can also be grounded on private data to be able to provide more accurate responses using patterns like RAG or be customized through fine-tuning techniques. Next, we have seen the emergence of triggered agents. This is one step further. They are goal-based and can take actions on their own. They are still based on LLMs since the model is the brain, the chat engine. But they can also access the data or search tools and actions or functions. They are semi-autonomous because they may require minimal user interaction, but they could also ask for help from other agents if you're building a multi-agent system. Given a goal, they will obviously work to achieve that goal without you knowing in advance exactly how it's going to do or what steps it's going to take to achieve that goal. So now when we have agent working as a team together, we call that a multi-agent system that can be built to address more complex scenarios where we want to provide fault tolerance. For instance, have one agent review the work of another one, or specializations, and each agent is expert in a specific task, and also scalability for large workloads. So in short, the agent should be able to accomplish 3 things. And again, you've probably also seen the slide before, but this is really important to understand. So the agent needs to reason over a provided business process. It needs also to integrate with data sources for a specific context and orchestrate a process toward achieving a goal by performing multiple tasks or actions. So an LLM-based agent is a framework that sits above one or more models that allow you to do complex long-running tasks, and that can also take action on your behalf. And that's also important to understand, like when having multi-agent system, you don't necessarily need to use one model. You can use multiple models, and each model obviously would be good at doing or performing in a particular environment or scenario. So for today's demos, we are not going to focus on multi-agent system. We're simply going to build multiple single application agents, but we will have different scenarios. And as you can see here, we'll have, I believe, like six scenarios, maybe 8 in the actual code. And for each agent we have here, we will have a specific prompt with a specific tool and specific instructions, just to demonstrate to you how you can build those agents. So I had actually a video prepared in case the live demo won't work, but let me actually go through the live demo. So I hope you're seeing my editor here. So I'm in the repo, and I'm gonna run the demo here. As you can see, Let me zoom in a little bit. So I'm gonna firstly I'm gonna run the demo, and then we're going to go through each scenario and see how it's built. So the first agent we have is a simple agent with no tools. It's just using its own core knowledge to resolve this equation. Let me choose one, run it, and then this is going to talk to Azure OpenAI using Azure AI Agent Service and give us hopefully a response by explaining how it's going to resolve this equation, x equals 1, obviously. The second scenario here is using a function calling or a function tool. And the purpose here, the scenario or like the demo, is to give me the CPU usage of my system, my computer that you see now. So this is going basically to have the agent, as you can see, my system is running at 33% load. And then have my code call that action that the LLM constructed, basically. So the fourth scenario, I'm just going to skip the third one because that's you're already familiar with that one, like code generation. The fourth scenario is using code interpreter, the code interpreter tool, and we are also giving it some data to analyze a file. I'm going to share with you like CSV file. It's going to run some processing, and also is going to give us some images, charts or graphics as images. So the file I'm giving it is I think it's car sales. That's the CSV one I'm giving it. So basically, it's going to go through this file, do some processing, and give us the output. So this might take a couple of minutes or a couple of seconds, but basically the downloaded images would look like this one, for instance, and it looks like basic charts. And all of these images got generated on a remote code interpreter session, sandbox session. And yeah, as you can see, it's replacing all the images. So these are the new one that got generated. So pretty cool, I think. Let's also go through the sixth scenario, and that one is using the Azure AI Search to also analyze some insurance coverage data that I already ingested into the index, which got vectorized and ready for the LLM to do some RAG operations on it. So basically here again, I'm asking it, what are my health insurance plan coverage types? So it's going to use that index search. It's going to give me a response with some, as you can see here, citations. So citing, excuse me. It's mentioning its sources or the part from the document that mentioned that specific reply or response. Anyways, we're going to look at that also into more details. The last scenario, which is using Bing grounding tool, this is going to fetch live information from the internet about the stock market and give me some insight. So hopefully we can buy or maybe sell some stocks. Who knows? So this is using the integrated Bing grounding tool provided by Azure AI Agent Service. Oh, that was super fast. Okay. So it's telling me that, closing last week. Okay, in a noble sector. Okay, might need to do more research before buying some stocks today. Anyways, so this is going to be our demo for this session. But first, before we dive into the demo, let me talk to you briefly about how we can build agents with JavaScript and Azure AI Agent Service. So as you might know, there are lots of frameworks to help us build agents, but some of them, to be honest with you, they leave devs with a lot of complexity. For example, you have to handle state, context, tool orchestration, and scaling, which can be so challenging, obviously. So we're going to use this new Azure AI Agent Service product, which is part of the AI Foundry family. So it's a platform that you can use to create intelligent agents with minimal code, quickly automate tasks like workflows and data analysis. It offers extensive data connections, seamlessly integrated, and seamlessly integrating tools like, as I mentioned, Bing Grounding, Azure AI Search, Fabric. So you have flexible model selections, including OpenAI, but also Mistral, Llama, you name it. Like, for instance, GPT 4.1 got released yesterday. It's already available in AI Foundry, so you can use it today. And also, which is more importantly, it ensures enterprise-grade ready and enterprise-grade security with keyless authentication and managed storage, and robust compliance. So speaking of enterprise-grade security, that's really, really important also to know, because security is a top priority when building agents, agent apps in enterprise environment, because your agents will handle sensitive data, interact with external systems, and must be protected from misuse. So Azure AI Agent Service is built to meet rigorous enterprise requirements with features like supporting tracing and monitoring, ensuring that your agent is not hallucinating, content filtering to protect you against various prompt attacks, bring your own storage and search for custom data handling, and also standard agent configuration with private networking, allowing you to bring your own VNet. And also, as I mentioned earlier, keyless setup and auth, which is amazing. So yeah, a typical solution architecture when building agent apps would look like something like this one. So you have your agent app. You will use some sort of framework. So we're doing JavaScript today. So the obvious few JavaScript AI frameworks that you would use are either LlamaIndex, TypeScript, or LangChain.js. So I like LlamaIndex. I'm using it as an example. If you also want to learn more about LlamaIndex, I believe Laurie will join us in this event to share more about how you can use LlamaIndex to orchestrate, build your AI agent applications and orchestrate them. With even cool features like MCP integrations, which is really new to everyone. On the API side, you would use something like Node.js with a API framework of your choice, and for the UI, you would use UI framework like Angular. I like Angular. Or if you don't have a UI like we do today, you could just use Node.js to build a terminal app. On the middle, you will see this Azure AI Agent Service manage instance, which handles models, instructions, and so many other features. And then at the bottom, you'll have your tools like Code Interpreter, File Search, Grounding with Bing, Fabric, as I mentioned, and tons of other integrations, as you will see later when I share with you the AI Foundry, my AI Foundry instance, and also actions like function calling. All right, so let me take some time, because this is going to be really important to understand how agents work under the hood. So when building an agent, there are like multiple steps that the agent workflow is going to go through. So first you will create your agent, then you will create and attach a thread to that agent. Inside of that thread, you'll then create a run, and you will have to check your run step statuses for different scenarios and different operations to be done. And yeah, once done, you'll get the response, and then you can delete your agent or leave it. And by the way, you can create agents and threads separately. They are not tied together. You can have like thread without specific agent or thread with multiple agents. So for instance, here we will have a specialized agent with specific instructions on its skills or personality or behavior or whatever you call it. Yeah, it needs to be precise and like really clear. And then you would use a model. As I mentioned, you have tons of of choices to choose from when using Azure AI Agent Service. And then they have the tools. You have few of them here in the slide, but we are adding more tools every day. No, that's not true, but like every continuously. And once you have that thread, as I mentioned, you will start this conversation. So a thread, like it's a conversation flow between the agent and a user, where you will have multiple like messages, replies, and actions through the run. So in this particular example for us today, we're going to ask our agent, which is an expert in weather forecast, what is the weather in the city of light. I am doing it on purpose here, not naming it Paris. I'm giving it a nickname because the agent will have to figure out, well, what city actually do we call the city of light. So I'm giving it three tools, function calling tools: get user favorite city, get user nickname, get weather. And we'll have to figure out which one to call in order to give me the response, which it does. And in a different scenario, I could also ask it, okay, so now show me that response as a chart. And in this particular case, the agent will have to figure out which tool to use. So it knows that it needs to generate visual data. So for this case, it's going to use code interpreter tool, as we saw in the demo previously. Anyways, so these are basically all the steps that an agent would go through when processing or doing its what it had, well, like it's the workflow that has to do. So for this, I actually, in order to really understand what's going under the hood live when you ask an agent to do something or for a specific task, to run a specific task. So to help me understand what's going on with the internals of my agents that I build every day, I built this tool. This is like a personal private tool. This is not an official tool. And basically, I will give it's tied to an existing application. And it's basically going to show you what's going on when you run a prompt. Each step, like you're basically tracing the flow of the actions and the information. Let me actually show it to you live. I have it running here. Yes. So the app, the UI that you see, is talking to a backend. And that backend actually is using an agent that is, well, the same than what I showed you in the slides. Is like an expert in weather forecast. So I'm going to ask it questions about weather, like temperature and everything. Needs to give me a reply. But first of all, let me ask it, hi, what's up? So here, on purpose, I'm asking it like a random question just to show you or to understand, is it going to call a function, a tool or not, or what's going to do precisely. So I'm running it here. As you can see, the agent is now uploading a file because I gave it some data to use for the weather. It also created a vector search tool, created an agent, created a thread, inserted a message, run the thread, go through all the steps, and then gave me a reply here. Hi there, not much, blah, blah, blah. Okay. And it's also giving me the usage or how many tokens it used. I can obviously record and replay all the events. I can pause them, go step by step. Anyways, that's not the purpose for today. This is just a fun project I created last week to help me understand and hopefully also help you understand what's going on with your agents. And if something fails, how you can debug it. Okay. So the next slide is about function calling, because that's one of the core features when using agents. So the function calling is the capability of the LLM to take user-defined functions as input and generate structured data. So OpenAI and other models support function calling. However, not all models support function calling, so you need really to be careful which model to use when you're building agents. And also some of them support single function calling, and some of others support parallel function calling. So make sure to choose the right models for your needs. And what we do here is basically you provide a function definition as a schema, and if the LLM detects whether that would satisfy a function, then you get a structured output, and it's then up to your app to decide what to do with that structured data. Let me go back to my tracer here. Now I'm going to ask it, yeah, just like weather in Paris, like really short prompt. Oh, let me restart. So this is still like a work in progress. It's not ready for to be used, but it's working. It's doing the job for me at least. So as you would see here, what I want to show you is here is not now. It's calling the function that I gave it, and it's going to go through all the steps for this particular run. And it gave me a reply. It's 22 degrees in Paris. Hey, that's fun. Okay. So as an example, again, you start by building your agent. You give it some precise instructions. The example I'm showing you here is the one for the CPU usage that we're going to check just after. And this is the function calling definition that we provide to the LLM. And if it thinks it should call it, then it will give us back a structured output with the function name to be called, because we can have multiple functions. So we need to know which function we need to call. And if needed, it also gives us the arguments. Well, in this case, we don't have any argument. But for instance, in get the weather example, we could probably have the city as the name, as the argument. Anyway, so yeah, enough talking. Let's check some code. So the first lab 0, obviously, we will just make sure to understand the basics by learning how to start building the agent step by step. So let me go back to VS Code. Here we have source labs basics. So this first file, this first scenario just shows you how to create the agent, like create an agent and delete the agent. By the way, let me start from the beginning, actually. So in order to build an agent with Azure AI Agent Service and Azure and TypeScript, we do have an SDK for you, which is at Azure AI Projects, that you will need to obviously install. So I think I'm using the latest beta from 2.8, beta 4, that's the latest one. You would also need Azure Identity to be able to access your agent or authenticate your agent without having any key to enter or token. Also, you will have to create an instance of your Azure AI Agent Service on Azure AI Foundry. When creating that instance, you will have, let me show you. So when you create that instance, this is this is AI Foundry on Azure. When you create that instance, you have to copy this project connection string, which is blurred here because I'm protecting myself. But you can just copy it and then go back to the project, create your .env file. This is the template we give you, and then copy it here. That's the one. Okay. Either way, I'm going to delete it after the live. No worry. So also, if you're using other services like AI Search, Grounding, you will have to copy your connection IDs in this environment file and name it .env to work. So for us, we have the basics, the SDK, environment variables, the connections, the connection name, connection ID. And then you will start by creating a client. You always need a client. And that client, you will create it from the connection string, which is in your environment variables. And then you will authenticate. In my case here, I'm using just the default Azure credential. I recommend you using a specific one like the CLI or any managed identity, just to be specific. And next, once you have the client, you're good to go. Actually, you access the agent's property, which gives you the create agent. You give it the model name, and by the way, you also need to deploy the model beforehand. Yeah, like give it a name here. I'm sorry, give it a name, give it some instructions, and that's it. Then you created your first agent. Let me just. I'm not going to delete that one. I'm gonna call it my AI Agent Hackathon. Copilot is helping me. I'm going to where is the terminal? Because I zoomed in. Okay, it's here. All right. npm run. So I have prepared a few npm scripts to help me. It's called basic. Yes, npm run basic. Okay, it's working. So once it's completed, yes, it's created the agent. Let's go back to my AI Foundry agent playground or agent UI, and hopefully you will see my AI agent hackathon created. So that's great. Now, I mean, I can just simply delete it. All right. So congratulations, you just created your first agent. Let me just. It's always good to clean your resources. All right. So the next step is to create, as I mentioned in my previous slide, create and attach a thread. So in this case, I'm just going to create a thread. And you guys, as you can see, I'm not creating any agents. I just need to create a thread in order, I don't know, if I have a use case where I just want to attach messages coming from somewhere and have some runs that be executed. So create a thread. All right, threads. Yes, that's plural because you can have multiple threads. Okay, created and deleted. And by the way, when you have threads, you could see them in the threads section in AI Agent, in AI Foundry. By the way, for instance, I have this stock market thread, and you can see, excuse me, where is it? Here, the thread. I have 2 messages in this one, and I think that's the one you saw from my Agent Tracer app. Yeah, it's stored here. Okay, so yeah, create a thread. Your thread is ready, and then you can. We'll see after, like, what you can do inside of a thread. For instance, you can store messages. So in order to store messages, then you will need your agent. As usual, create agent, then create a thread. And then you can start creating your messages and attach them to a particular thread using the ID. In this case, I'm creating a message from the user, from me, hello world, and storing it in the conversation thread with the agent. And also I can list messages just to check all the messages I have in my thread. Messages, yes, plural. So again, really simple in like 1, 2, 3, 4 lines of like API calls. You can have an agent created, your first message inserted, and your thread ready. Obviously, the rest is like cleanup again. Yeah, really simple to do with JavaScript. So streaming, that's like a basic feature that you see everywhere. Streaming is like having this, like this. Your messages are doing like basically what ChatGPT standardized. So your Delta messages are coming up as they are produced by the LLM and not buffered. So for that, again, you create your client, create your agent, create a thread, insert your first message. Hey, agent, tell me a joke. And then you will have to create and start what we call a run. As I mentioned in my slides previously, a run is like a stream of operations that the agent is doing in order to accomplish a goal. In this case, it's gonna basically create, come up with a joke, because that's what you asked it, and then provide you with a stream of characters that will build up basically the response. So in this case, in order to use the streaming feature, you need to call the agent, create a run, give it the agent ID and the thread ID, and then call the stream method. This will give you a stream of events. Then you will wait for all those events and check for the events that, or the operations that you care about. In this case here, we're just checking when a particular thread has been created by the Azure AI Agent Service, and then we have like other threads, other events just for login. And basically in here, once we detect that we just created the thread, all the message delta are being constructed, then we grab those deltas, characters, and then we build up our text value, which is our message. Let's try it out, actually. I'll stop talking. What is called streaming? Am I consistent at naming? Yes. So again, create an agent, create a thread, create a run, and then we got our joke. Sure, here is a light one for you. Why don't skeleton fight each other? Because they don't have the guts. Ha ha ha. Okay. So yeah, streaming is super easy. You could like connect this to the rest of your app, or for instance, send it as a buffer to the UI if you have a UI, and then like construct a nice chat app like the ones you see everywhere. I think the last building block are the runs, as I mentioned. Runs are basically, I see them like as the core of what your LLMs are doing under the hood, because like when an LLM needs to decide whether it should call an action or, call a tool or execute an action or anything else, it will do it a part of a particular run. So again, here, if you forget about all the console logs, again, maybe like 10 lines of API calls, you have like a usable getting started, I should say, run. So again, create an agent, create a thread, start your first message, and then you create a run as we saw earlier. In this case, we are not interested in the streaming feature from a run. We just create one single run between the agent and a thread. And what is great about runs is, again, as I mentioned earlier, they trigger events. So all you have to do is listen for the events and run some specific actions in your code. So in this case here, we are interested in the queued in progress and requires action events from the run, and just like logging them. We're not doing any particular thing with here, just like trying to understand how things work under the hood. They're also like part of one single run. You could see multiple steps, and those which I showed you in the tracing app earlier. This is exactly where actions happen. So you can list those steps if you're also interested in them to get the actual data, or again, if an LLM needs to call a tool, you would fetch the name of the tool, the name of the arguments, the value of the arguments, and everything from that data object. Let me run. Did I call it runs or ran? Ran. Okay, run. Oh, that's funny. That's funnier than the joke that the LLM told me earlier. Okay, we created our agent, created a thread, inserted the message in a thread, created a run, checked for the completion, and then started listing the steps for that particular run ID. And yeah, that's actually, I think it's actually easy to reason about. So anyways, this is the really like simple building blocks, I should say things you need really to understand when starting building agents. And to be honest with you, I was making jokes earlier. This is using JavaScript. The API is so simple. This is the same thing with Python and other languages. The API also might, for those who knew or are familiar with the OpenAI Assistant API, this is kind of looks similar. And the difference here is that you have like more tools and enterprise features on top of that. Anyway, so I think the next step for us now is to look at the actual demos that I showed you in the beginning. And this is the core of the repo. If you forget about the labs folder, in order to build like I always say, usable agent app, using the same building blocks actually I showed you, like there is nothing different here. The only difference is that we are architecting the app like in a maintainable way and composable way. So for that, we have a config file with all the prompts that will basically represent a particular agent. So the solve equation, I consider this as a single agent. It has its specific instructions. For instance, you are a math agent, use your knowledge to solve the equations. And by the way, please avoid doing or having this short instructions. This is just for demo purposes. in a real world use case, you will have like a clear, long instruction for things like a do and don'ts for your agents, just for it not to like hallucinate or because the thing is, like, LLMs, specifically LLMs, are like non-deterministic. So sometimes if it happens to me multiple times, if the LLM doesn't want to call your function, it's not going to call it unless you specify that in your instructions. And yeah, we have like different prompt for different use cases. And you see the ones using the Bing grounding that I shared earlier, the AI search, code interpreter, and so on and so forth. And for the demo here, so where is the index? So here basically what we're doing is to in our app here is like basically grab the prompts, display the prompts, ask the user to choose one prompt. We get that prompt, and then we create an agent and process the prompt that users chooses. And for that, we build the tools list using this tools service. So in here, basically, based on the prompt that we chose, we construct a tools definition that we need to pass to the LLM, to the agent. And for that, we have this tools array, and we have the tool resources object. The tools array is an array of tools definitions. So in this case, we have a code interpreter. We can have an Azure AI Search, Bing ground definition, or function schema definitions as well. There's basically a list of tools that the agent needs to use. The tool resources object is a list of resources, like files, data, that the agent or the LLM needs to use part of a tool call, for instance. So yeah, once we have our tools and tool definition, we simply create an agent, as I showed earlier in the building blocks. We create an agent with instructions. We give it the tools resources object and the tools array. For the rest, just forget about them. That's not really important for us here. Next, we create a thread. We add the message to that thread, and then we run the agent. Running the agent means basically going through the run steps in order to check for the operations that we care about. And in our case, we will check for different operations, whether we're running no tool at all, a function calling, a code interpreter, a Bing search, and so on and so forth. And everything basically happens in this thread service. Here we create a run. That's the function that we need. So we're creating a run and as a stream, as I mentioned earlier. Basically, we're interested in all the events, and we're checking for every event coming up from that from the LLM. If we we get the deltas, the message characters, and sometimes also, because we in our case we can run like code on a code interpreter remote sandbox. In this case, we will probably have an image file or like non-text data that we also need to check. For the function calling use case in particular, and let me show that to you. So here, so for the function calling tool, as I mentioned, we need to pass a function schema definition to the tool, and for that, we just have in this particular project, we have a helper class that lists this schema in our case, It's a get CP usage with a particular description and no parameters. And then the actual code that needs to run, that we need to execute part of this function definition is this one here. So this is the exact code that's going to run on my computer to basically give me my usage. And this code is run by our app. It's not run by the LLM. It's not run by the agent. We take the responsibility actually to run this function. And we do that in the thread here. Whenever an LLM needs to run an action, it will trigger this requires action event. So we need to listen for that event, and then we process the event. And yeah, it's a bunch of glue code actually to just make sure we have we actually have the name of the function available, and then we can invoke it here, and then get the response. And which is something that's important also. Whenever you run an action function tool, the response, the result you get from that invocation, you need to basically provide that back to the agent, so that it could incorporate that and give you the final response. Yeah, and that's basically that's the core of the function calling scenario. And yeah, I think we've covered like the important pieces here. Let me go back to the slides. I think we're almost, yep, we're almost done. So we covered the basic building blocks. We covered the scenario where we call an agent with no tools. That's like the simplest scenario. The one with function calling, again, this is really important to understand. And actually, once you figure out how to do it once, it's easily, you can do it. You can simply replicate that. I showed you an example with one function. You can actually provide multiple function definitions, as I mentioned in the previous slides, and then the agent will figure out which one to call based on the prompt. Code interpretation, that's also something that we demoed. I actually forgot just to show you one thing about the Azure AI Search integration, because that's really important to figure out if you want to integrate AI search in your agent. So first of all, you need to create an instance of Azure AI Search on Azure portal. On Azure, using the portal or the AZD or the AZCLI. And yeah, once you have that Azure AI Search instance ready, you create an index and you populate that index with your own data. But also, you also need, that's really important, to create a vectorizer that's part of your index, because this is going to be required by the Azure AI Agent Service configuration. So have that ready and have it also assigned to your profile. We have docs, we have documentations on how to do that. Don't worry. So yeah, once you have that in the integration, manage center, connected sources. So here, when you basically connect an integration or add an integration, that's the Bing search here. That's the Azure AI Search connection ID that you need to use in your project actually to have it run, to have it executed. So yeah, that's something I wanted to share with you actually, because it's important to have that ready. So yeah, Azure AI Search, we saw that. And I think, yeah, we have a few minutes left just to conclude. So the learning and the next steps. To summarize, some key takeaways. Build agents quickly with Azure AI Agent Service, which is a fully managed service, as you saw from the previous presentations. Use it to get out-of-the-box tools, again, like real-time search with Bing, Azure AI Search for RAG use cases, function calling, code interpreter if you want to run code safely on a remote execution environment, or even get some charts, some image graphics. Something we haven't demonstrated, which is file search. And by the way, if you are interested in the demos and the next step, we will be pushing changes and updates to the, new features and updates to the repo, to the GitHub repo. And we will be adding this file search because we don't have it ready yet. So if you're interested, please subscribe to that repo. And also, you can explore frameworks such as Llama Index TypeScript to implement like more advanced functionalities with multi-agent system, with MCP integration, for MCP tools integration, for instance, which we didn't cover part of this presentation. And yeah, we used, I showed you how to use code, but also you can use AI Foundry Playground to tinker and like try out agents, connect tools, basically do everything in there to like start, like getting started and everything. Yeah, so I think we're almost done. Again, please take some time to check out the repo that my team and I are maintaining. We will be adding more features to that one. If you have a suggestion or you want to contribute, please feel free. It's open source. And yeah, stay tuned for that one. So my last slide is about generative AI for beginners. So this is a free curriculum written in JavaScript that my team put together just for you. So if you want to keep exploring and learning about building agents with JavaScript and TypeScript, I think this is the curriculum for you. So please check it out. So yes, I think I am done for today. I will be, I don't know how much time do we have left, because I see a lot of comments there. So I'll pick up maybe one or two questions to answer. And also, yeah, please feel free to reach out to me after the talk on the internet. You will find me somewhere on social media if you have more questions. So I see Diego Lamaro, I hope I'm pronouncing your name correctly. When to use tool function calling and when to use MCP? So that's a great question, actually. So MCP is a hot topic right now. It's a new becoming standard, actually, for your agents to explore and not explore, to fetch tools from remote servers. So to answer your question, Diego, I would say if you've built an MCP server, or if you have one or can use one that provide tools you need, and if it's secure, if you're trusted and everything, please use that one. And on the framework side, on your app side, you would use the MCP client to fetch the tools and use them. So my short answer is whenever you can use an MCP server, please use that one. It's easier for your application maintenance. All right. I think we are done for today. So yeah, thank you for tuning in. Please reach out to me if you have any questions about JavaScript, agents, Azure AI Agent Service. Thank you.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.